The major problem in LED light technology resolved by mimicking the Larney turn pattern of Firefly. Can you believe it? Around 70% of light sources in nightlife around the globe is from LED technology. Domestic LED light, commercial LED light, industrial LED lights, street light LED lights, search lights, decorative LED strips, and more from LED technology. The technology bring down the power usage in lighting industry to very small size. But LED lights still facing a new challenge. Here it is. LED light bulbs play a key role in clean energy. Overall commercial LED efficiency is currently only about 50%. One of the major concerns is how to improve the so-called light extraction efficiency of the LEDs. The researchers are focused on how to get light out of the LED. Fireflies and LEDs face similar challenges in releasing the light they produce because the light can reflect backward and get lost. One solution for LEDs is to texture the surface with microstructures, microscopic projections, that allow more light to escape. In most LEDs these projections are symmetrical, with identical slopes on each side. Struggling to overcome this problem, an international team of researchers looked to the Firefly lantern. They found that the lanterns had an exoskeleton that was jagged with protruding scales and a tilted slope. This prevented reflection and let most of the light out.
Nicholas Andrey at the University of Sherbrooke in Canada used lasers to create a similar texture on LEDs and saw that they shone with 1.5 times more intensity. Engineering inspiration from highly ordered cuticular nanostructures of a firefly light organ. A. The optical image of a firefly, L. lateralis mochulski, in male. The SEM images of B. Abdominal segments of a firefly in male including normal, N, and lantern, L, cuticles, C. Amorphous nanostructures on the normal cuticle, D. Highly ordered nanostructures on the lantern cuticle and E. A transverse cross-section of the light organ. F. Transmission of bioluminescent light, lambda equals 560 nm, through nanostructured surfaces on the lantern cuticle calculated by the FDTD method. The results show the maximum value at 250 nm in period, 150 nm in width, and 110 nm in height, very similar to natural one. This result clearly explains that the highly ordered cuticular nanostructures surrounding the ventral photogenic layer contribute to high extraction of bioluminescent light outside the lantern cuticle. Anatomical comparisons between G, a firefly lantern, and H, a high-power LED package. Inspired from a firefly lantern comprising a dorsal layer, a photogenic layer, and a cuticle, a high-power LED package has a similar configuration of a reflector cup, an LED chip, and a lens with nanostructures. Like the cuticular nanostructures of a firefly lantern, the nanostructures on LED lens surfaces can serve as highly efficient extraction of the LED light for a high-power LED package.